Hey guys, so someone asked me about this problem here. So we want to find the x-intercepts, if any, of the parabola y equals 3x squared minus 2x minus 4. And there's a couple ways to do this. The best way to do this is to use something called the quadratic formula. We haven't learned it yet. I've been very deliberate in not showing it to you because I want you to actually complete the square. Often if we show students the quadratic formula too early, they always use it. It's important to make the connection that the quadratic formula is simply completing the square, but done in the general case. We'll talk about that later. At our stage, we have two ways to do this. One is we could factor and set y equal to 0. So if I look at this, I could write 0 equals 3x squared minus 2x minus 4. I could try and find the product. I could do decomposition here. And the factoring is not ideal. So in this case, it's not the best approach. The other way we can do this is we can complete the square. When we complete the square, we end up in vertex form, and the nice thing about vertex form is we can actually solve for x when y is 0. So what I'm going to do is I'm going to write y equals 3x squared minus 2x minus 4. And what I'm going to do now is I'm going to complete the square to change this to vertex form. So the first thing I'll do is I'll factor out that 3 from the first two terms. Okay. And what I'll do now is I'll take this value here and I'm going to add and subtract what I sometimes call the magic number, though I tend not to like that term now more and more because it's not ideal. But what we're going to do is we're going to take 2 over 3 and we'll divide it by 2 and then square it. So I come up here, I'm going to say negative 2 over 3 over 2 squared, and that's equal to negative 2 over 6 squared, which is equal to negative 1 over 3 squared. Now, we could work out negative 1 over 3 squared as 1/9, but I actually encourage you to leave it like this when you substitute it. And the reason why is that by putting in this nice number, this is now a perfect square. So it actually factors very nicely. Oh, pardon me. So if I say x squared minus, so when I factor this trinomial, it actually factors to x minus 1 over 3 squared. See that? See why that's nice? You could square that and you get 1 over 9, but then you have to think about what it factors to. Now I'll square the second one. So I'm going to say minus 1 over 9 minus 4. And now what I'll do is I'll expand this back out. So equals 3x minus 1 over 3 squared. 3 times 1 over 9, negative 1 over 9 is going to be negative 1 over 3 minus 4. Now we'll do a little simplification. 3x minus 1 over 3 squared minus 1/3 minus 12 over 3. So we get 3x minus 1 over 3 squared minus 13 over 3. So now I've written this in vertex form, which is great because if I set this to 0, the algebra is pretty straightforward to work out the values of x. So if I set this to 0, I'm going to say 13 over 3 Now what I'll do is I'll multiply both sides by 1 over 3, so I'm going to end up with 13 over 9 So that's a little rough work from before. So now I'll take the square root of both sides. So I'm going to have the square root of 13 over 9, and don't forget I have to put that plus or minus. So therefore x is equal to 1 over 3 plus or minus the square root of 13 over 9. So those are the x-intercepts. Now, depending on your background and what algebra work you've done, you could write this in a variety of ways. I'm perfectly okay with the fact if you just take this and plug it into a calculator. However, if you don't have a calculator, I think it's good just to leave it like this. If you don't have a reason to change it into a decimal, leave it. So those are the two x-intercepts. The first x-intercept is going to be 1 over 3 plus the square root of 13 over 9, 0. And the other x-intercept is going to be 1 over 3 minus the square root of 13 over 9, 0. And we're done. So with this problem, if we want to find the x-intercepts of a parabola, ideally if we can factor it quickly, that's great. The other way to do it is to go through this process of completing the square, because in doing so we end up with vertex form. And vertex form means that we can then easily solve for x if y is 0. If you get these fractions, just leave it like this. If you're graphing it, plug in your calculator, get a decimal, and it's easy to approximate. Again, what's come up a number of times in class is this thing called a quadratic formula. Some people have actually given it to us, and that's a great tool which we're going to learn and we're going to use more and more. However, we want to make sure we know where it comes from. And the quadratic formula comes from completing the square, but instead of using numbers here, we put A, B, and C. And that's a video for another time. I hope this helped.